Balancing of the redox reactions through oxidation number method. Oxidation number method. This oxidation number method is usually applied for any redox reaction in which neutral molecules participate. It can also be applied even for the reactions in which ions participate. So for any type of this species, this reaction can be applied. So let us take oxalate. This is oxalate. This is oxalate. Next, let us take potassium dichromate. This is potassium dichromate. This potassium dichromate will always act as the oxidizing agent because the oxidation state of the central atom, that is chromium, is +6. Hence, chromium will always gains the electrons. Hence, potassium dichromate will always act as the oxidizing agent. Next, this oxalate or oxalic acid will always act as the electron supplier or reducing agent. This will act as the reducing agent. This will act as the oxidizing agent. Now, let us balance the reaction between these two species through oxidation number method. I am representing the oxalate as a C2O4 2-. Next, when K2Cr2O7 participates, the active species involved in the reaction is Cr2O7 2-. Therefore, I am showing only Cr2O7 2-. Now, let us conduct this reaction in alkaline medium. Now, the reaction is taking place in the alkaline medium. Now, in the alkaline medium, let us say this C2O4 oxalate has been oxidized into CO2. Next, dichromate has been oxidized to Cr3+. Cr3+. This is the net reaction that is taking place in the alkaline medium. Now, we want to balance this reaction through the oxidation number method. So, in this oxidation number method also, the first step is the identification of oxidation state of each and every species. Now, let us observe the oxidation state of the carbon here. The oxidation state of the every carbon here is +3. The oxidation state of the carbon here is +4. That means for carbon, there is change in the oxidation state. Now, identify what type of change that is happening. For carbon, there is increase in the oxidation state. Hence, we can say carbon is undergoing oxidation. Similarly, chromium. Observe the oxidation state of the chromium here, +6. The oxidation state of the chromium here is +3. Therefore, here, +6 to +3. Therefore, here there is a decrease in the oxidation state. Hence, it is called reduction. That means one species is undergoing oxidation, the another species is undergoing reduction. Next, here in this oxidation number method, we need not split the entire reaction into two halves. Without splitting, directly we can balance the reaction. So therefore, first, what is the first step to balance this reaction through this method? In the first step, first identify the atoms whose oxidation state has been changed. For which atoms oxidation state has been changed? For carbon as well as for the chromium. Since there is change in the oxidation state of the carbon and chromium, therefore, first you balance the carbon and chromium atoms. Before you start the actual process, you balance the carbon and chromium atoms. See, here two carbon atoms were shown, here only one carbon. So, by keeping suitable number before the formula, we can balance the carbon atoms. Similarly, chromium atoms also. Here two chromiums were shown, here only one chromium is shown. Therefore, first we balance the carbon and chromium before we start the actual process. oxalate plus dichromate plus OH minus. Here put 2, it becomes 2CO2. Here Cr2O7, you put 2, it becomes Cr3 plus. So now the oxidation state of the carbon and chromium are changing, and their numbers are different from reactant side to product side. Therefore, first we have balanced the carbon and chromium atoms. Next, after balancing the carbon and chromium atom, now identify the total charge difference of the carbon atoms and the total charge difference of the chromium atoms. Total charge difference. Here each carbon is in +3 oxidation state. Therefore, total charge is +6. Here each carbon is in +4 oxidation state. Therefore, total charge is +8. +8. Therefore, total charge difference is how much? 2 units. 2 units. Next, for chromium. Similarly, here for each chromium, the oxidation state is for each chromium the oxidation state is +6. This side each chromium oxidation state is +3. Therefore, total oxidation state is +6. Here total oxidation state is +2. Therefore, the total change in the oxidation state is 6 units. So first identify the total charge difference between the oxidizing species, total charge difference between the reducing species. For oxalate, the total charge difference is 2. For chromate, total charge difference is 6. 2 and 6. Next, in the next step, exchange these numbers. That means you keep this 2 in front of the dichromate. You keep this 6 in front of the C2O4. Exchange the differences. So if you exchange the differences, here we will get the 6 C2O4 2 minus. Next here 2 Cr2O7 2 minus plus OH minus. Next here we have kept the 6. Therefore, this side also we have to equalize the carbon number. 6 means total 12 carbons. Therefore, directly put the 12 carbons. Here 4 chromium atoms. Therefore, make this side also 4. After balancing the heteroatoms, now we have to balance the oxygen atoms. For balancing of the oxygen atoms, first the total number of oxygen atoms on the left side as well as on the right side. Here on the left side, 6 into 4, 24 oxygen atoms here. Here 2 into 7, 14. So 24 plus 14, 38 oxygen atoms are present. Let us count this oxygen later. 38. Here 38 oxygen atoms are present. This side 24 oxygen atoms are present. So therefore, which side excess of oxygen atoms are present? This side. This side deficiency of oxygen atoms are present. So how many oxygen atoms are deficient? 14 oxygen atoms are deficient. Therefore, first identify the side in which deficiency of oxygen atoms is existing. This side there is a deficiency of oxygen atoms. Then identify the number of oxygen atoms which are deficient. Here how many deficient? 14. Therefore, here 14 oxygen atoms are deficient. This side 14 oxygen atoms are excess. Therefore, now in order to balance the oxygen atoms in alkaline medium, add the number of water molecules which are suitable to balance the oxygen atoms. 6 C2O4 2 minus plus 2 Cr2O7 plus OH minus. Here 12 CO2 plus 12 4 Cr3 plus 14 H2O molecules have to be added. This is separately one more OH group is there. For this OH group also include the water molecule. Therefore, total 15 H2Os. Now you cross check the total number of oxygen atoms here. Here already 24. Here 40. 38 plus 1 39. Here 24 plus 15. So 39. So oxygen atoms have been balanced. Next, after balancing the oxygen atoms, then we have to balance the hydrogens. Next, after balancing the oxygen atoms, Now we have to balance the hydrogen atoms. So for balancing of the hydrogen atoms, again you just verify which side is excess, which side is deficient of the hydrogen atoms. Here in this reaction, on the left side we have only one hydrogen atom. On the right side we have 30 hydrogen atoms. That means 29 hydrogens are excess this side. 29 hydrogens are excess. Therefore, first identify which side the excess of hydrogens are present. Whichever side excess of hydrogens are present, that many number of OH groups have to be added. Then if you add the OH groups in the same step, simultaneously we have to add the same number of water molecules to its opposite side. That means in this entire process, on the excess side OH groups have to be added. To the deficient side H2O, so that means water molecules have to be added. Therefore here, this is the original reaction. 6C2O4 2 minus plus 2Cr2O7 2 minus plus here OH groups, here H2Os. This side extra hydrogens are present. This side we have to add the OH groups. This side we have to add the water molecules. So this is the original OH group. Now we have to add the water molecules. How many water molecules we have to add? Here 29 hydrogens are extra. Therefore this side we have to add 29 OH groups. If you add 29 OH groups this side, to its opposite side, same number of water molecules have to be added. That means 29 water molecules have to be added. Next, this side 12 CO2, 4 Cr3 plus, here 15 H2 plus 29 OH. Now you can cross check whether oxygen atoms have been balanced or not. You can cross check whether hydrogens have been balanced or not. Now you see all oxygen atoms have been balanced. All hydrogens are also balanced. Before we have started the process, the carbon and chromiums have already been balanced. Then after balancing the carbon and chromium, through the exchange of these numbers, we have balanced the charge present on the reactant side, charge present on the product side. Now this is the net reaction. Next, after deriving the net reaction, so if similar terms are present on both sides, you can cancel them. Therefore here one OH minus is present, here 29 OH minus. Here one OH minus, eliminate. Next here 29 H2O, here 15 H2O. From this 15 H2O and here 15 H2O, remove. So net reaction is C2O4 2 minus. Next 2 Cr2O7 2 minus. Next this side 29 OH groups are present. This OH group is present this side. We have cancelled this OH group. Therefore this side we don't get the OH groups. Next water molecules. Here 29 water molecules are present. Here 15 water molecules are present. So this 15, here 15 you cancel them. So still how many will be left? 14 H2O. 14 H2O will be left. Next 12 CO2 plus 4 Cr3 plus 28 OH minus. Now all the atoms under the charge have been balanced.